Welcome back to this video 4-4. This is curve sketching with some calculus in it. In this video, we are going to go ahead and look at example 2. If you missed example 1, make sure you cover that. We talked about the curve sketching recipe. Okay, so here is example 2. And I want to refresh your memory with our curve sketching recipe. We have steps 1 through 6. These steps really are our pre-calculus steps in analyzing a function. And then steps 7 and 8, this is where the calculus comes in, where we take the first derivative and the second derivative. Okay, so here is our example, and we have f of x equals 3x minus 2 over x squared minus 2x plus 1. Now, I'll do all of the pre-calculus concepts in red here, and then I'll do the calculus portion in green. But it says the first thing on our menu is domain. So for domain, I have a rational function. Remember, rational functions, we can't have the denominator be 0. So I need to factor this denominator, which it happens to be x minus 1 squared, right? So x minus 1 cannot be equal to 0, which produces x cannot be positive 1. Okay, and when that happens, since nothing canceled here, we don't have any holes, we have a vertical asymptote at x equals 1. Now, our x-intercept, I just, again, want to take our function and set it equal to 0, right? X comma 0 is our x-intercept. So 0 equals 3x minus 2. Our denominator will just disappear. So this gives us an x-intercept at 2/3, or 0 at 2/3. So 2/3 comma 0. And then our y-intercept, I will just go ahead and evaluate the function at 0. And when we do this, we get an output of negative 2 over 1, which is negative 2. So 0, negative 2. Okay, and then our end behavior. Our end behavior, again, is coming from the ratio of the terms. So I have little over big, and in this case, we have a horizontal asymptote at y equals 0, right? And if we want to write this as a limit, so as x goes to positive infinity, the function is equal to 0, which is also equal to the limit at negative infinity. Okay, so there's our end behavior. And then symmetry. This function, it doesn't look like it has any even or odd kind of properties, so there's no symmetry here, none. Okay, all right, so there is our pre-calculus portion. Now what we have is our calculus portion. They want the relative max, the min, and the points of inflection. So what we have to do is we have to analyze our f prime of x and our f double prime. So our f prime of x, I'll go ahead and make a f prime sign analysis chart. Okay, and for this, again, I want to know, okay, when is f prime equal to 0? So that's going to be negative 3x plus 1, and this gives me a 0 at negative 1/3. Okay, no, sorry, positive 1/3. Positive 1/3. Okay, and then also, too, our function is undefined at x equals 1, right? We have a vertical asymptote. Okay, so at 1, we have a vertical asymptote, and then at 1/3, we have a critical number, a 0. Okay, so we'll go ahead, we'll do some sign analysis, and we'll test some values. Okay, so I can plug in 0 into my f prime, and this gives me 1 over negative 1, so we're decreasing on that interval. If I plug in 0.5 here, okay, so 0.5, that will give us a negative over a negative. Okay, so that's positive. And then over here, I can plug in something such as 2. That will give us a negative over a positive, and that's negative. Okay, so there is f prime. I know that our function is decreasing and then increasing, and then after the asymptote, it is decreasing. Okay, next I want to go ahead and I want to analyze f double prime. F double prime. And f double prime, we have, again, the zeros is when is our function equal to 0. So I'll just take the numerator, 6x equals 0, which tells me I have a possible point of inflection at 0. And then we also have our undefined value, again, I'll put parentheses around this, again, here at x equals 1. So I'll make a straight line. Here's 1. Again, we have an asymptote here, and zeros over here. Okay, so I want to test some of these values. Okay, so I'll test a negative number. When I plug in a negative, I'm going to get a negative over a positive. So that's negative. Okay, then I'm going to plug in 0.5. You can just go with -1 there. So 0.5. I plug in 0.5. Okay, we get a positive over a positive, so that's positive. Okay, and then we'll plug in 2. So we get a positive over a positive, so this is also positive. Okay, so what does this mean? Well, it means we're concave down here, and then we're concave up here, and then we're concave up here also. Okay, so let's go ahead and, we forgot the maxes, the mins, and the points of inflection. So a minimum, again, a minimum occurs when we go from decreasing to increasing, okay, and that's going to occur here at 1/3. So I have 1/3, and then to plug that in, I'll analyze 1/3. I want f of 1/3, and we'll get -9/4. Okay, so -9/4, right? I'm going to plug that into f of x here. Relative maximums, that's when we go from increasing to decreasing, and we don't have any of those, so we'll say none. And then points of inflection, when do we go from concave down to concave up, or vice versa? Okay, and that's going to occur here at 0. Okay, so I'll plug in 0, and then I need the output. So again, I'll go back to my function, f of x, we'll plug in 0, and we get -2. Okay, and you can remember we got that same point here for our y-intercept. So our y-intercept, -2, that is a point of inflection. So let's go ahead, let's mark these key features. Vertical asymptote at 1. No holes. X-intercept at 2/3, 0, so right there. A y-intercept at 0, -2. Okay. My end behavior, I have a horizontal asymptote at 0. Okay, I'm going to do that. And then I'll also do this. I left it blank in here because this rational function comes up and pops up through here. Our end behaviors approach the horizontal asymptote, but that horizontal asymptote doesn't apply for the whole function. And then we have, our relative minimum at 1/3, -9/4, so that's -2 right there. Okay. And here's where we're going to use our calculus. So starting from the left, I know I'm going to approach my horizontal asymptote. I am decreasing from -infinity to 1/3. Okay, so decreasing. And I am concave down from -infinity to 0. So concave down. I hit this value, and then as soon as I hit this value, we change to concave up, and then I come up here. Okay. All right. And then on the other side of our function, okay, our function is decreasing, and it is concave up. So I have this function, and I approach here too. Another way that you knew that you were going to be decreasing or coming down here, also is from your vertical asymptote. Your vertical asymptote is even, right? It's a square. Okay, so even vertical asymptote will give you that look. All right, so that's it for this example. Please go ahead and watch the third video. It will be on the third example for this. Catch you next time. Peace.